Hi everyone, Mr. Thompson here with a physics video lesson. Today we're talking about speed and velocity and some other things that go along with speed and velocity and what we need to know for those things. So here we go. The first thing we'll talk about is speed. Now the good thing about speed is most people have a pretty good idea of what speed is in general. Of course we have to overcomplicate it and give a super technical definition. So the definition that we will make is a rate of movement over a distance. But basically that just means how fast something is moving, okay, which we all sort of probably have a pretty good idea about, okay. First thing, when we're measuring speed, right? We're measuring how fast something is going. When we measure something, we need to have the units. So the units for speed are always going to be distance divided by time. Some familiar ones that you probably know, or one familiar one would be kilometers per hour, okay, but we'll also see meters per second quite a bit, okay. If you're in America or somewhere else that uses imperial system, you'll have miles per hour and things like that, but meters per second is pretty universal. Even in America it gets used quite a bit. To calculate speed, you do pretty much exactly what the units kind of imply. You divide the distance by the time. Okay, so for example, if a car is driving and in 2 hours it covers 160 kilometers and we need to find the speed, we will divide that distance by the time. So the distance is 160 kilometers, the time is 2 hours. So 160 divided by 2 is of course 80, and that was kilometers divided by hours, so kilometers per hour. All right, pretty simple. Now, here's the thing. It's possible that this car was on cruise control and stuck at 80 k's per hour for 2 full hours and just went straight and didn't stop, didn't slow down, didn't speed up. But most of the time, that's not how it works. Most of the time, maybe you're going 100 maybe or something like that. Maybe then you hit traffic and you slow down, or maybe you stop for a rest or a fuel or something like that. Okay, and so usually when we do something like this, we talk about average speed. Okay, so let's look at a scenario where we have stops and starts and different things, different speeds, and we'll look at finding the average speed. So for this scenario, we have 1 hour of going 100 k's an hour. Okay, and let's just, for now, we'll just kind of assume that that is straight up 100 k's an hour exactly, or whatever. Really, all that matters is that for that first hour, it's an average of 100 k's. And then we stop for 30 minutes. Okay, and then another 30 minutes, we're going to go 120. Okay, and I don't know, we can just assume that we're on the German Autobahns or something where somewhere we're allowed to go 120. And we want to find the average speed for that whole time. So it's that full 2 hours, the first hour, the half an hour where we stopped, and the next half an hour. We want to find the average speed for that 2 hours, say like the average speed for the trip or something like that. Okay, it's the total distance divided by the total time. Now, for this situation, we're not given distances. We're actually given speeds. So we kind of have to work backwards and find the distances for that first and third part, right? So we can take this equation for speed and rearrange it using algebra. Okay, we can multiply both sides by time, and then on the right hand side, time cancels on the top and the bottom, and we can then rewrite this as distance equals speed times time. Okay, and we can use that for the first and third leg of our trip here to find out what distance was covered in that time, and then we can use those to find the overall average speed. So they're pretty obvious, but the first hour is 1 hour and 200 k's. So we do 100 times 1. And of course, if you're going 100 k's for 1 hour, you go 100 k's. The last 30 minutes where we're going 120 k's, that's 120 times 0.5, right? 0.5, because 30 minutes is half an hour. We need to keep our units consistent there. So hours and hours on the speed and the time. So 120 times 0.5 is 60, right? So that's a total of 160 k's over 2 hours, right? So that's exactly like that situation we looked at before. This might be one example of what that one was illustrating. 2 hours, 160 k's. So the average is 80 k's per hour as before. Okay. Okay, what we can do now is we can round out these equations. We've got speed in terms of distance and time, and we've got distance in terms of speed and time. We can solve that one more time and get this solved for time, for if we ever needed to calculate time given speed and distance. So to do that, we divide both sides by speed. Speed cancels out on the bottom and left on that right hand side, and we get time equals distance divided by speed. Okay, now I'll clean these equations up for you. They're sort of the trifecta of calculating speed, right? Solved for speed, distance, and time. You don't have to like memorize all three of them. You definitely want to at least know that first one. And I just think of speed limit signs on the highway, right? Distance divided by time, kilometers per hour or miles per hour, and that kind of thing. And then I just rearrange that with algebra if I need to find the time or find the distance. I just do that mathematically. But if you want to write them down and memorize them, that's great. Go for it. Okay. Now, this video is about speed and velocity, so we need to talk about velocity. But before we do that, we need to talk about a couple other concepts first. And I want to talk about what the sort of limitation of speed is. When we have speed, we have a speedometer that is what usually tells us the speed. We also have these little odometer things that tell us how far we've gone, or the trip meter, right? Those instruments don't distinguish where we're going, or whether we're going this way or that way, backwards or forwards or whatever, where we start and where we end up. They just are numbers that tell you how fast you're going at the moment and how far you've gone overall. And that's what speed is really about. Speed is just a measurement of a certain time, or an average over a certain time. Velocity, similar, but velocity takes into account which way you're actually going. Okay, so before we can talk about velocity, we need to talk about two concepts: position and displacement. Okay. Now, position hopefully is something that everybody sort of has an idea about what it is. It's your location. Okay, it could be on a map, could be your position along a route, or it could be on a grid like a maths grid, or on a globe on the GPS and that kind of thing. Okay, so it's just where you are or where something is. It's a designated location. Okay, now displacement is the distance and direction between a starting and ending point, two designated points. All right. Now distance, hopefully that's fairly obvious. It's just the length between the starting and ending point. The direction might be a little bit more confusing. Direction can mean lots of different things, and in any given problem, it'll be explained to you what that direction means. But it could mean stuff like forwards, backwards, left, right. It could mean north, south, east and west, and that kind of thing, or bearings, or it could even be three-dimensional through space and things like that. But for now, we're going to simplify it. We're just going to talk about direction along a line, back and forth, right? Basically just a number line, moving left and right along a number line. And we're going to do this with things like cars and objects moving, or blocks falling, things like that. And we'll have, as we see here, a starting point and an ending point. Okay, so if we have a little green dot, and our little green dot starts at that starting point, and then let's say it moves beyond the end, and then comes back again, and it finishes there at the end. Okay, the displacement is the distance between the start and end. So it's only this distance between those 2 points, right? We basically ignore all that extra space that was traveled. Okay. Similarly, if we're going in sort of 2 dimensions, and we go up and then down again, sort of like that, the displacement is just a straight line between the start and end. Okay. Another funny thing about displacement is that if the start and the end are the same place, say we go out and then come back again, the displacement is 0, right? It's sort of your net movement. It's the distance between start and finish. Okay, now if we just defined another point along this path, then that would not be 0, right? The distance between the start and somewhere here in the middle, that would not be 0. But if we take it all the way to the end, the displacement is 0, okay? So now we can talk about velocity. Now, velocity is easy. Once you've covered speed and displacement, velocity is really easy because it's exactly like speed. It's distance over time, but instead of using distance, we use displacement. Okay, so you have to take into account the starting and the finishing and which way we were going. All right, so we have V for velocity equals D for displacement, not distance, over t for time. Okay, and just a little note, the v for velocity, a lowercase v, it's like a script v, so sometimes it looks a little curvy like a u, and it has a little tail sticking out to the right here or whatever, rather than a u, which would have the line going down on the side. Okay, let's look at a couple of quick examples, and then we'll be done here. So we have a timeline, we have A to B, and it's marked as meters, and we're told that we go from A to B in 5 seconds. Okay, so if we count up the little lines from A to B, it's 10, so that's 10 meters in 5 seconds. V is 10 divided by 5, so 2, and it's meters divided by seconds, so meters per second. Easy, right? Here's another one. We go from A to B to C, right? So it starts out here at A, goes all the way to B, comes back to C, right? And it says 12 seconds. So we count up the distance from A to C, start to finish, right? And it's only 6. So that's 6 meters in 12 seconds. So that's 0.5 meters per second. The velocity from start to finish is 0.5 meters per second. Okay, that's like the average velocity from A to C. Okay, how about a race car going 50 laps around a track at 200 kilometers per hour? Right. Well, the start is the same as the finish. So the displacement is 0. So the velocity is 0. Okay, and that just highlights the difference between velocity and speed. The speed is, your current motion, your movement at any one time, and total distance, whereas displacement is just the difference between the start and the end. If the distance is 0, the velocity is 0. All right, that's it for today. Next video will be on acceleration. Talk to you then.